KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, we are going to discuss the intensity and intensity distribution and photograph of fringes due to the diffraction at single slit. In our previous class, we discussed the single slit experiment and we observed the diffraction pattern due to the single slit. So there itself we derived an expression, that is what we derived a condition. We derived condition, right, for what is that intensity at 0 and intensity at maximum, right. So what is the condition for intensity falls to 0? That is theta is equal to n lambda by a. Theta is equal to n lambda by a. Next, theta is equal to n plus 1 by 2 into lambda by a. N plus 1 by 2 into lambda by a. So these two conditions, the conditions to see or to observe the minimum intensity or intensity falls to 0, and whereas the second condition, that is for theta is equal to n plus 1 by 2 into lambda by a, is the condition for maximum. So you can see the fringe with the maximum intensity, right. So how these two conditions we derived and how it is possible to get the minimum intensity or 0 intensity at theta is equal to n lambda by a, and how it is possible to see the maximum intensity at theta is equal to n plus 1 by 2 into lambda by a, where n is equal to plus or minus 1, comma plus or minus 2, comma plus or minus 3 and so on, right. At the same time, what happens to the central bright fringe and where it is going to form? Afterwards, that is what towards the top and towards the bottom, how the brightness is going to decrease, how the brightness will become decreased. What happens to the fringe just after the central bright fringe towards the top direction, towards the top, and what happens to the next fringe towards the bottom. So that and all we discussed in our last class. So that is totally single slit diffraction experiment. Single slit diffraction experiment. Okay, right. In continuation to that, it's not a separate class, just in continuation to the last class, here you can observe the diffraction pattern clearly, right. So yesterday also I drew one picture. That picture is experiment, that picture is experimental setup. Where is the position of arbitrary point P and where is the position of central bright fringe, that is what C. What is the width of the slit, that is small a, and what is the path difference between the two light rays and where is the source. So that is totally experimental setup. But this picture what you are seeing in this class, is this is the screen. Here you can see the amplitude, see here, right, which is, so based on that, okay, you can see here, it is the central bright fringe. So it is the fringe after that towards top. So like positive y-axis. It is the next one, is the second one, second fringe from here. Suppose if it is like 0 means it is 1, it is 2. Suppose if we are not giving any number here means it is like 1, 2, this is like 1, 2. But it is like along a positive y-axis and it is like along negative y-axis. So you can see and you can say that the brightness is going to decrease. That's already given in our last class, already given in the form of information that we are seeing here, right? So it is the slit, it is what a single slit, right? It is what the source of light. If you observe carefully, so this is what I already written here, that is what incoming wave. Incoming wave, this is the viewing screen. So if you observe carefully, this is what it is, the screen, it is the opaque screen. Here there is no chance for the light to enter from this side to that side. But here whatever the amount of light is going to pass, this light is going to diffract. See here. If there is no diffraction, if light is not going to diffraction means whatever the light comes here, it has to fall only, it has to cover only this part of screen. See the red light mark. Only this part of the screen. But what's happening? Entire screen, whatever the screen is present here, the entire screen is going to be illuminated by the light. Entire screen is going to expose to the light. Based on this, you can say that when the light ray meets sharp edges, see the red light, it is one of the sharp edge and it is another sharp edge. Whenever the light meets sharp edge, then it will bend. See here. So this is called as diffraction. Okay, right. And the intensity distribution and photograph of the fringes. This is the photograph of the fringes, the central bright fringe and next fringe and next fringe, and this is also towards the bottom or along negative y-axis. Due to the diffraction at single slit. This is what single slit. Okay, right. Now what I am saying is, we just before I think 2-3 classes, right? Okay, anyhow, in the same chapter, wave optics, just before 4-5 classes or 2-3 classes, we discussed interference, which is also one of the very important property about light. Being a light is propagating in the form of wave, interference is also one of the important property. There we discussed what is meant by interference, and before that what is meant by superposition, because superposition is the basic principle to understand the interference, right? So what is superposition principle, what is interference, how the light is going to interference, right? We also discussed Young's double slit experiment to observe the interference pattern on the screen. So now why I am talking about interference means there is like very small difference between interference and diffraction, that we have to understand, right? And it is not correct to say that both are same, but there is small difference. If the situation dominates, if the parameters, if the conditions, if the assumptions what we are taking, if the dimensions what we are taking dominates, we have to say both are same. But generally we can't say both are same. There is some difference, right? So many theories, so many scientists, so many persons, right, tried to distinguish what is the interference and diffraction. What is the difference between interference and diffraction? Okay. From the discovery of this diffraction, many scientists try to distinguish the difference between interference and diffraction. But one of the famous book, Feynman lectures on physics, the scientist has written in this manner. So it is the famous, right? So now we are going to understand the difference between interference and diffraction. So this information helps you when you are going to do the problems related to either interference or diffraction. So in this information, from this, what is that? No one has ever been to up to here. That is what is more often used. Every word is important, every line is important, right? So you please be focused here. Say this. No one has ever been able to define the difference between interference and diffraction satisfactorily. It is just a question of usage and there is no specific important physical difference between them. There is no specific important physical difference between them, right? So what he is saying here, no one has ever been able to define the difference between interference and diffraction satisfactorily. It is just a question of usage, and there is no specific important physical difference between them. Next, the best we can do is, roughly speaking, is to say that when there are only a few sources, say two interfering sources, then the result is usually called interference. But if there is a large number of them, if there is a large number of sources, it seems that the word diffraction is more often used, right? So whatever the experiment we did, whatever the experiment we discussed, that is what Young's double slit experiment, there are two slits to observe the interference pattern. But in case of diffraction, we are using a single slit. Single slit means you have to imagine the combination of large number of slits, right? So from this information, from this paragraph, he is concluding that we can get the conclusion, we are getting the conclusion that when there is a large number of sources, you can say we have to use the word diffraction. When there are few number of sources, means very less number of sources, like 2. For example, Young's double slit experiment means there are only 2, we have to use the interference. So based on this paragraph, based on this information, you just imagine what is the difference between interference and diffraction. Okay, right. And you can see one more picture here. This picture is showing us actual double slit interference pattern. Right? So the envelope shows the single slit diffraction. Right? So that is. So this picture is showing both. That is what if you use double slit interference pattern, what happens and how can we see? At the same time, this envelope shows the single slit diffraction. Okay, right. Meanwhile, regarding this picture here itself, I will tell you some other information. See here. In double slit experiment, what we already discussed, right? The pattern on the screen is actually a superposition of single slit diffraction from each slit or hole and the double slit interference pattern So whatever the experiment we discussed, that is what Young's double slit experiment, he is saying that suppose if you take single slit diffraction and there is another slit, because there are two slits in case of Young's double slit experiment now, from one slit diffraction and another slit diffraction, right? So that is what he is saying is Young's double slit experiment, the interference pattern in case of Young's double slit experiment is the superposition of single slit diffraction from each hole. So his conclusion is the interference pattern what we are obtaining in case of Young's double slit experiment is the superposition of single slit diffraction from each hole. That is one. Okay, right, that you can see in this picture also, right? And one more point is here, wherever the broader diffraction peak in which there are several fringes of smaller width. See this. There are several fringes of small width due to the double slit interference. Right? And one more thing is the number of interference fringes occurring in the broad diffraction. The number of interference fringes occurring in the broad diffraction peak on the ratio d by a. On the ratio small d by a. So that is the ratio of the distance between the two slits to the width of a single slit, right? So what he is saying is the number of interference fringes occurring in the broad diffraction peak depends upon the ratio d by a. D is the distance between the two slits in case of Young's double slit experiment, and small a is the width of the single slit, right. And in the limit of small a, that is the width of the single slit, becoming very small, the diffraction pattern will become very flat and we will observe two slit interference pattern. So what he is saying is, if you decrease the small a, that is the width of the single slit, too small, that is very small, then you can see the interference pattern what we observed in case of Young's double slit experiment. Young's double slit experiment. Okay. So this is the information we have to discuss about this picture, right? Okay. Afterwards, we are going to discuss the next continuation, that is one example problem here, that is example 10.5. Example 10.5. See here. In example 10.3, what should the width of each slit be to obtain 10 maxima of the double slit pattern within the central maximum? In example 10.3, what should the width of each slit be to obtain 10 maxima of the double slit pattern within the central maximum of the single slit pattern? Within the central maximum of the single slit pattern. So, to solve this example problem, we have to take the data from example 10.3. So, with the help of data from example 10.3, we have to find width of each slit to obtain 10 maxima of the double slit pattern within the central maximum of the single slit pattern. Within the central maximum of the single slit pattern. Okay, right. So what is the width of the each slit, right? Okay. This formula, you know, that is what A theta is equal to lambda. A theta is equal to lambda. Theta is equal to lambda by A. Theta is equal to lambda by A, right? A theta is equal to lambda. Theta is equal to lambda by A, right? So this formula we know from last class, that is single slit diffraction. If theta, actually A sin theta is equal to lambda, for smaller values of theta, A theta is equal to lambda, theta is equal to lambda by A, right? But if you apply that to here, to this situation, you can write it as 10 lambda by D. 10 lambda by D is equal to 2 lambda by A. 10 lambda by D is equal to 2 lambda by A. 2 lambda by A, right? Okay. And if you do that mathematical calculation, right? If you do the mathematical calculation here, here it is lambda will get cancelled, lambda will get cancelled, and A is equal to D by 5. So D value already we had in our last example problem, that is what example 10.3. According to this question, we have to take the data from 10.3. So it is 1 mm. So 1 by 5 is equal to 0.2. So for this question, the answer is 0.2 mm, 0.2 millimeter. At the same time, we also need to remember the wavelength of light and distance of the screen. Wavelength of light and distance of the screen do not enter in the calculation of A. He is asking to remember, he is asking to find wavelength of light and distance of the screen. Wavelength of light means lambda, here it will get cancelled. Distance of the screen means capital D. So this lambda and capital D has no effects in the calculation of small a that we calculated here, and the answer is 0.2 mm. Okay, right. And now we are going to see some other differences, some other clear differences between interference and diffraction. Because for example, in our Young's double slit experiment, in case of interference, Suppose if you close one slit, what happened? What will happen? In our Young's double slit experiment, if you close one slit, what will happen? You can see amounts to the, you can see the light which is passing through a single slit. Okay. Then you have to take care of that some shift in the pattern. When two slits are there, what happens to the light on the screen? What happened to the pattern on the screen? If out of the two slits, if one slit is closed, means what happens to the pattern on the screen? So we need to observe some shift. We may see some shift, right? So that's why if we have a source at S and there is only one hole, either S1 or S2, this is like what? Single slit diffraction pattern on the screen. So in Young's double slit experiment, if we close one slit, anyone, either S1 or S2, we have to see the single slit diffraction pattern on the screen. The central bright fringe will appear at a point which lies on the straight line S1 or S2, wherever it is. Suppose, I don't know whether you are going to close S1 or S2, right? That is, okay. Now we are going to discuss some other differences between interference and diffraction. Okay, see here. First, see here, the interference pattern has a number of equally spaced bright and dark bands. The interference pattern has a number of equally spaced bright and dark bands, whereas the diffraction pattern has a central bright maximum which is twice as wide as the other maximum. In the same class, I showed you just before, I think just before 10 minutes, while starting this class, I showed you one picture. That is what a pattern, the pattern of bands, right? How, what about the central bright fringe and next fringe along positive x-axis and next fringe similarly along negative x-axis or towards bottom, what happened? Okay, that and all I showed to you, right? Okay, now that you have to once recall into your mind. See here, the diffraction pattern has a central bright maximum which is twice as wide as the other maximum, full stop. The intensity falls as we go to successive maxima away from the center on either side. Okay, so he is saying the difference between interference and diffraction. In case of interference pattern, having number of equally spaced bright and dark bands, But in case of diffraction, central bright is maximum, right, which is twice as wide as the other maximum. Full stop. The intensity falls as we go to successive maxima away from the center on either side. Next. Second, see here. In case of interference, by the superposition of two waves originating from the two narrow slits. Is it correct or not? Because Young's double slit experiment also completed for us. So when I am explaining something, you have to recall the information what we already discussed and you just compare whether it is correct or not. Okay. So in case of interference, what we experienced? We experienced that the superposition of two waves took place and the two waves originating from the two narrow slits. Right. In case of diffraction, see here, superposition of a continuous family of waves originating from each point on a single slit. Superposition of a continuous family of waves originating from each point on a single slit, right? So in the single slit, each point you have to treat, we have to consider as a source of waves. That's why he mentioned one word, that is what? Continuous family of waves. Continuous family of waves, right? So this happens in case of diffraction. Next, in case of third one, while discussing about the differences between interference and diffraction, third important point, see here. For a single slit of width small a, the first null of the interference pattern occurs at an angle of lambda by A. At the same angle of lambda by A, we get a maximum, right? See here, for a single slit of width small a, the first null of the interference pattern occurs at an angle of lambda by A. At the same angle of lambda by A, we get a maximum for two narrow slits separated by a distance A. So, he is comparing Young's double slit experiment to the single slit diffraction experiment. Single slit diffraction experiment. So, please understand the last point where he is going somewhat for calculation, means showing the angle in terms of wavelength and width of the slit. Width of the slit. Okay, right. Afterwards, he is also saying that small d in case of Young's double slit experiment and small a in case of single slit diffraction experiment have to be quite small to observe good interference and diffraction pattern, right? So, the small d in case of Young's double slit experiment and small a, that is the width of the single slit in case of single slit diffraction experiment, to have small values, to be quite small to observe good interference and diffraction patterns. For example, the separation small d between the two slits must be the order of millimeter. Similarly, in case of single slit diffraction, the width small a of each slit be even smaller, that is the order of 0.1 or 0.2 mm for good interference or diffraction pattern. Okay, right. And in continuation to that, in our discussion, right, in our discussion, the Young's experiment and the single slit diffraction, we assumed that the screen on which the fringes are formed is at large distance, that is what capital D, that is what capital D, right? We have assumed that the screen on which the fringes are formed is at a large distance. Okay, and next, the two or more paths from the slits to the screen, were treated as parallel, right? So, the situation also occurs when we place a converging lens after the slits. If you place a converging lens, that is what convex lens after the slit, okay, after the slit, you can also see the same situation, and place the screen at the focus. So, you just keep a convex lens just after the slits and you place the screen at the focus of a convex lens. Okay, so that is, but in practical, the lens does not introduce any extra path difference in a parallel. The lens what you are going to introduce does not introduce any extra path difference in a parallel beam, right? So, the same experiment whatever we did is changing by using a small convex lens. So, whatever the task we are achieving is also possible to achieve by introducing a convex lens between the slits and the screen, that he is saying. Okay, right. And this arrangement, whatever the arrangement of introducing convex lens and keeping the screen at the focus of convex lens gives more intensity than placing the screen far away, right? So, you can increase the intensity of the pattern, right? If f is the focal length of the convex lens what we introduced, right, and you can easily work out the size of the central bright maximum. Suppose in terms of angles, the separation of the central maximum from the first null of the diffraction pattern is lambda by A, So, that is why the size of the screen will be f lambda by A. The size of the screen will be f lambda by A. Okay, that is. So, in this class we focus to see, we concentrated to learn what is the picture, what is the photograph, right? What is the photograph of fringes due to the diffraction at single slit, and then we discuss the differences between interference and diffraction. This is the major information from female lectures of physics, and this is the picture which is showing both interference and diffraction. right? Afterwards we discussed one example problem, then we discussed another 3 important differences between interference and diffraction. Afterwards we discussed the consequences of introducing a convex lens between the 2 slits and the screen, so that you can increase the intensity, and you can also calculate, that is what, size of the screen, that is f lambda by a, f lambda by a. Okay, thank you. We will continue in the next class.